write up the title, and I think it's even a bit different than the one submitted. And then last weekend I was putting the talk together, and I think you should never do that. You should never do that. So, but we will see if it works out. So this is a bit like the talk at ESUG 2014, which was about cathedrals and toilets. This one is instead about perfection, feedback, and why everything that exists sucks. And of course, what to do about it. So the first thing is, I have very bad news. Perfection does not exist. And the best quote that I found about it is from this guy: if the world would be perfect, it wouldn't be. And it's from Yogi Berra, who I know from the jargon file a long time ago in Linux. And I always thought that this was some yogi, but he's actually a baseball player, which is really funny. But he has lots of cool quotes. Another one is, I really didn't say everything that I said. Which is true. There are lots of quotes that are said from him that he never said. So very nice. So perfection doesn't exist. And one reason is, of course, that we all learn when we start to be programmers, is by the time you get the perfect solution, the problem already changed. So there cannot be the problem will be different, and so your solution will not be perfect. Another one is context. I think this is very interesting to look at. Context defines everything. And it's, so for one, imagine you would build the perfect Smalltalk system for now, which would be perfect in 1995. Would it be perfect now? Of course not, because there are far more resources that we can use. The context of where it's internet and so on is completely different. So the perfect system would not be perfect. Context is everything. And it goes, of course, in one way that the perfect solution is not perfect because of context, but can even go the other way around. Something that you think is horrible, actually might be not that bad in a certain context. So there is this video that you, I think, all know. It was one of the first viral videos of the internet before YouTube. And it's of course a bit of a sad video because someone filmed, or he filmed himself, and then someone leaked the video, so a typical bully situation, and there's lots of discussion about it. But what everyone kind of agrees on, it is kind of bad, the moves that he does, and funny. But actually that's not true, because the context that he had while he was doing it is not conveyed in the video. And so some years ago, someone actually said, I need to actually make a video that shows the context that he had while doing this. And then it looks completely different. Changes constantly, and that's why it's very difficult to find something that is good in every context. We could have said, of course, everyone stops doing anything until I create the perfect thing. Does not really work. Another problem, which is really interesting to look at, is that while you build something, you are learning. So imagine you have an idea of where you want to go, and it is so great and amazing. You start to build. 2 years later, you actually manage to build what you wanted to build. The problem is that you learned over the whole period that it actually is not, you could even do better. I mean, you learn so much, and you look at it and it looks boring, it looks obvious, it looks like that you should actually stop doing it, throw it away, and start from scratch, because it's not perfect. But if you look back, the old you 2 years ago, if he would have given, if someone would have said, oh no, I did it already, here it is, you would have, wow, this is amazing. And everyone else is on that level. So that means if you would finish, even though it's a bit boring because it's so bad, everyone else is on your state 2 years ago and will say, yeah, this is amazing. So think about that. If every time you feel a bit down that your cool project is so boring and obvious and bad, it's not. But to some extent, it actually is. Because everything that you can finish, because you're learning and you kind of try to get the essence out of it, this essence of its own not perfection will be obvious inside your artifact. So that means if you, and that's a bit the sad thing, so if you finish and you give it to someone, it might actually be obvious the next step. And that's every time, so when you look at other people's projects and after 5 minutes you find how it could be better, this is not because you are so clever, it's because the other person embodied the critique inside the artifact. And you see that a lot on Y Combinator when someone presents something. It is always destroyed, and that's the reason, because it embodies its own critique. And it's so obvious to say, yeah, but you could have done X. If you would have done X, then it would be clear that you would have done Z. And it never stops. So, okay, there's no perfection, but it could be better, couldn't it? Look at the things. And of course, what you can say, those who could have done better are really busy to build the perfect solution. Which is a bit funny, but there is something else at play besides that. A force completely incomprehensible to mankind, and that is exponential growth. And I want to explain a little bit. But there's a very nice video which explores more the negative side of it, with population growth on YouTube. The most important video you ever see, it's I think 8 times 10 minutes by a mathematician, El Bartlett, who died some years ago. It's really nice. And he says the greatest shortcoming of the human race is our inability to understand the exponential function. And you say, no, I know, I saw all the things. I mean, everyone knows that. You know? I mean, who doesn't? I mean, in school maybe. How much rises on the chessboard at the end? Does it fill this room?
2 to the power of 64. Big number.
Yeah, so it's actually 1,000 times the global production of rice in 2010. Which is still mind-boggling, even so you know it. Yeah. Or a famous demo of the famous riddle of the lily pond. So you have a lake, there is a small lily, first day, second day there's the second one, and it's a fairly big lake, so it takes 47 days to fill up the lake half. How long will it take until it's fully covered? And it's clear that if you know it, it's clear it takes 1 day, because it's a doubling growth. First 1, then 2, and at the end it's half full, so doubling as full. So doubling, and that's what people think, yeah, doubling. But things don't double. I mean, we only have these small improvements, and small improvements are boring. Who would do a small improvement? We need to do big improvements, big changes. And there is what you need to know is that actually exponential growth does not need a doubling all the time. So for example, imagine you have we are Smalltalkers, so in 1983, we decided to start to pay 100 euro and buy an index fund of the S&P 500 until today. So we paid $40,000, quite a lot of money, but $100 per month, I guess we managed. So how much is that now, if you would sell it today? What do you think?
90.
So taxes are not considered because you only pay them after selling, but the index fund was interest. So it's actually $241,000. And this includes all the crisis and all these things. And the reason is that it has a growth of around 8% per year. And you are reinvesting with everything. You don't sell, and you reinvest all dividends, and so you arrive at 241,000. And of course, if you sell, you pay 50% taxes, so it's actually not that much money, but But it's interesting. So it's not, so exponential growth is not about doubling per se. So some people think, oh, if you don't double, who cares about 2% improvement? The thing is that as soon as you have a linear improvement that you feed back, it is exponential. It's only stretched out a bit. So that means if you have the rule of thumb is that you divide 70 by the growth number and you reach the doubling time. So for example, if you have 8% growth, then your account doubles every 7 divided by 8 years. So 7% growth, you need to double every 10 years if you have a growth per 10 years, which is actually amazing and much more than you intuitively would think. And of course, your reaction should be either capitalism is doomed to fail, or I need to actually invest tomorrow, or both. Yeah, and so interesting is that most value is actually created by reinvesting, and not by, so your $100 per month is irrelevant. It's the fact that you put stuff back and it earns more. And what it actually is a feedback loop. So you take all what you get, you put it back in the system, and it starts to grow exponentially. And there are lots and lots of examples for feedback loops. I mean, science itself is a feedback loop. So the whole idea why we publish, which we always forget, but that's the idea, is that the idea is out there and that someone else can use it. So someone published about calculus, and sometimes later we can go to the moon. And you could not do that if you wouldn't reuse the results. So it's a feedback loop that feedbacks ideas into humanity. And it means that there are new ideas thinkable that are unthinkable without the prior step. Open source is actually, why open source works is not because the source code is out there. It's completely irrelevant. It's a feedback loop. So if you look at, for example, Minix versus Linux, there are lots of discussions in the 90s about it. Minix was clearly and is clearly the better operating system. Yeah, it's really nice. Microkernel, beautiful. It's even open source. The source code was always available. The license was a bit strange, but that was even fixed. But nevertheless, Linux is on billions of devices and Minix not. And the reason is feedback loop. Linux is not an operating system, it's a process of feeding back changes into the project itself. Processor design. If you nowadays look at the processors that you can buy, you could not build them without having a computer already. So there are people, of course, that say, all the current processors are completely bad, we need to throw everything away and start from scratch, which is true, but could you do that with paper and pen? It would be a bit the same as if you go back to sticks and stones, the same craziness. Yeah? You would, of course, use the shitty Intel processor to design your new processor, which is completely bad. Or Lam Research, as a company. Their machines use microprocessors to build microprocessors. Without microprocessors, that would be harder to build. Yeah? So it's a feedback loop. Or the whole agile development thing. I mean, why do we write tests? Why do we have a debugger? All these things, it's all feedback. You want to have feedback very quickly so that you can actually react and grow. Or lean startup, minimum viable product. This is about the fact that the startup doesn't have the resources to build a perfect solution to the problem that nobody has. Yeah. And it's funny, it's really difficult to explain to people like us. And there's a whole kind of self-help book section about just that problem, which is really funny. So how does these things fit together, perfection and feedback? And the thing is that feedback loops do not care about perfection at all. The system where a feedback loop happens only needs to be good enough to sustain the next iteration of the feedback loop. And it does not care about the quality. So even in a horribly, horribly bad system that we always complain about, or all these kind of systems, if it's good enough to sustain the next iteration, a feedback loop can happen. And there is nothing that you can do against it. You cannot say, feedback loops, I don't care. It will be perfect when it's finished, and this other system, in a feedback loop, who cares? It's not true. As soon as something is in a feedback loop, if you don't have one, you can be as perfect as you want. There's nothing that you can do against, that you can compete. So what can we do, actually? So the first thing is, goals versus systems. So this is actually from the self-help book community, which is kind of funny, and it's a really nice idea. So they say that people always have goals, like I want to lose weight, I want to get more into sport, and all of these things, eat healthier. And it's really difficult to do if you ever tried it. It's much, much harder than you think. And so one of the ideas that people have is that they say, you should never try to do that goal, but you should try to build a system that has this goal at the end automatically. So instead of losing weight, you should maybe change some parameter that will lead to that. Slightly eating more or less. Yeah. So it's very interesting. And I think that we can actually understand the artifact that we are working on as a feedback loop too. Everything exists in a feedback loop. Every kind of thing. So for example, imagine, so in industry, that you have a feedback loop. I mean, you need to sell something that you get money that you can pay someone to make it better. Feedback loop. And this is true for if you have a spare time project to build a perfect system. Even there, it's kind of obvious. If you would build a shitty version of it and be able to sell it to someone, maybe you could not work in your spare time, but for a while full time, and you could progress. So even there, a feedback loop is always very interesting. But it's especially better in meta systems. So we are building IDEs, programming languages, and there it's clear that if you improve your IDE, what you can do changes. So you have an immediate feedback loop. I improve my IDE, I am a little bit more productive. And it gets even more if you have a reflective system. So if your system is implemented in itself, then every change that you do will change everything else, improve everything else. So for me, Smalltalk always, I mean, for me it was kind of always the idea that Smalltalk is a feedback loop. Nowadays I say Smalltalk can be a feedback loop, because what I found out is that most people actually say, no, don't change anything. So, if you set up the development and the community in the right way. If you're an open source project, if you ignore all contributions, that's not a feedback loop, for example. The second thing is we need to accept imperfection. It does not exist, so stop trying to block things happening just because you could do better. And there's actually a funny poster that I think at Facebook they put in all engineering offices, which is this. Done is actually better than perfect. And the reason is the feedback loop. I mean, Facebook wants a feedback loop, and they cannot build it on something that is unfinished but better. Yeah? So done is actually better than perfect. Another thing that is important, small change matters. So it's often that people say, no, it's so important in our project, only a big change is important enough. If we do a small change, that's boring. Who wants just linear, small, trivial, boring improvements? But as soon as you feed back your tiny improvement, it actually is not a tiny, linear, boring improvement. So, for example, a small change, imagine you would have done a tiny change that would make everyone a little bit more productive 30 years ago in your Smalltalk system. What payout would that change have over 30, 40 years? It's actually a lot. And it's much more than you would imagine, this trivial. If I would have that problem, I would fix it tomorrow, but it never bothered me. Yeah. Another thing is that if you are in a feedback loop and you do a tiny change, so I make something a little bit better and it was actually quite easy and boring, project yourself 10 iterations back and try to do the same. And you will see that this tiny change actually back then would have been really complicated and really difficult. So that means that what a tiny change is changes over time, and a tiny change today is actually a huge, complicated, impossible change some iterations ago. And one nice video that I found for this effect is actually this.
And there are 13 dominoes. The largest domino, it weighs about 100 pounds and is more than 1 meter tall. Ready?
Boom.
13 dominoes. If I had 29 dominoes, the last domino would be as tall as the Empire State Building.
And it's actually important. So what you would say, this tiny domino, who needs that? I can topple even the biggest one. So why do we even bother with these small ones? And what actually is the case is that you need to get the system going. It's not about, imagine you say, oh, I only topple the domino that is so big that it's the last one I can topple. And then it fails, which I call the Peter principle of the domino. Yeah? and you see that in people, especially intelligent people, do all the time. They do not want to bother about trivialities, and they wait until they reach the point where they just cannot do it anymore, which is very interesting. And doing the small, if the small one would have failed, it would have been so easy to tweak the system a little bit, and at some point it works, but if you just topple the last one, there is no way. So, goals versus systems. That's kind of the message that I want to say. And there's actually a very nice video which has a slight different direction, very important too. So I actually cut out the middle part of it to fit it into our topic. And it's about life and music, which is very nice.
In music, one doesn't make the end of a composition the point of the composition. If that was so, the best conductors would be those who play fastest. And there would be composers who wrote only finales. People go to concert just to hear one crashing chord. So that's the end. We thought of life by analogy with a journey, with a pilgrimage, which had a serious purpose at the end, and the thing was to get to that end. Success or whatever it is, or maybe heaven after you're dead. But we missed the point the whole way along. It was a musical thing, and you were supposed to sing or to dance while the music was being played.
Thank you.